Okay, so after the motion of moon around the earth, that is of 27 to 28 days, and it always faces the earth. Now let's check out the phases of the moon, that how moon will always face the earth, and what in 27 to 28 days, what are the phases of the moon when it is moving around the earth. So let's suppose on right hand side we are having a sun. So we are having a sun on right hand side. Okay, so we are having sun on the right hand side, and in center we consider the earth surface. So we are having earth in the center. Now let's start talking about the different phases of the moon. So first of all, starting from the new moon. So let's suppose we are starting from this side. So this is our 0 degree, because now we are starting from zero. There will be no rotation till now. So starting from zero, we are having a new phase of the moon. That is the new moon, which is like a line or a circular line, or you see that when we observe the new moon, just like in Ramzan and just like for Eid, we have to observe the moon. So initially the shape of the moon is very sharp and very thin, so that is very difficult to observe. If the sky was clear, there was no cloud, and all atmosphere is very clear, so that will be easy for us to observe that moon. Otherwise the shape of that moon is very much sharp, so that is not visible with normal eye. That's why we use telescope to observe that new moon, right? So that is the initial phase or the starting phase of the moon. This is known as the first phase, which is new moon, right? Okay, set.
Yes.
The second mode is when we consider the second mode. So second mode is between 90 and 0 degrees. That is, we can say that around 45 degrees. So we are having the second phase of the moon, and that second phase of the moon is, it will be like now this, and this is known as waxing crescent. So the word we used, crescent, that is also for the moon. So that is for the specific shape that takes after the half, or you can say that after rotating about 45 degrees with the earth. So after few days, we observe the moon like in this shape, which is known as the waxing crescent. So that is the second phase of the moon, right? And next, if we move towards the 90 degrees, so here we are having the 90-degree angle. So at 90 degree, what will be the shape of the moon? Any idea?
It will be thinner,
More thinner, or now it will be thicker as compared to the new shape?
thicker.
Yes, it will be thicker, and now the half moon will be completed over here, just like this. So this is the new shape of the moon, and we can say that this is the first quarter moon. So this part of the moon is known as, or this phase at 90 degrees known as the first quarter moon. And now if we same goes with the same angles on the other side, now we are moving between 90 and 80 degrees. That is in between like this. So we are having a different shape of moon. So what will be the new shape?
Full moon?
Okay. So now we are going to observe the full moon, but a little bit less far than the full moon, because if we compare it with 0 and 45 degree, so same there is a difference between a full moon. So that is around 135 degree. So now if we consider at 135, so we are observing the new shape of the moon, which is not completely full, but it is almost completing the full moon. But that was not complete, so it will be like in elliptical shape, not in a complete circular shape. So we observe the shape of the moon like this. This is not completely circular or not completely round. And that part of the moon is known as the waxing gibbous moon, which is not completely or the full moon, but it almost having a full shape of the moon. And we get the full shape of the moon after 180 degrees. So we observe full moon over here on the opposite side of the 0 degree. So that is the full moon. And after the completion of this full moon, now moon is again going towards the other cycle, or now it is going to convert into the moon of the new month. So now it starts reducing, or it will again become the thinner as compared to the previous shape or the previous thickness of the moon. So that is around, if we consider the new shape, that is 225 degrees. So now we again observe the same type of the shape, that is elliptical shape, which we observed in waxing gibbous moon. So that will also observe again over here, because now moon is going to be reducing the shape, and the name of this phase is the waning gibbous moon. So that is simple when we are talking about the elliptical shape. So that means the gibbous phase. There are two different phases for gibbous. One is waxing and the second one is waning. So this part is waning gibbous moon. And if we move towards the opposite side of the 90 degree, so in the opposite side of 90 degree, we will observe again the quarter moon, same like the previous one. So again, we observe the quarter moon, but that is not the first quarter. That is the last quarter, because now we are not going to observe the complete moon. So that's why we are covering the last quarter of the moon. and the final between the 0 and 360-degree angle, that will be the last phase, and that will be opposite to the, what will be the last phase? Any idea?
Crescent?
Yes, that is now crescent part, but that is waning crescent, just like the waning gibbous moon we discuss over here. So that will also go same for the crescent moon, but that will be waning crescent moon, right?
Yes.
Which is around 315 degrees. So again, we observe the new shape of moon, and that is the opposite of the waxing crescent, that is the waning crescent. So that is the part of the different phases of the moon, right? So normally when we are talking about the new moon phase, so basically when we are talking about the new phase, so in the diagram you observe that a new phase of the moon is between the earth and the sun, right? So new phase is between the earth and sun. That's why it was very difficult to observe the new moon, because of that the sharpness of the moon, and secondly it is between the sun and the earth, so that why it is difficult to observe the new phase of the moon, right? Because of the sunlight, so sunlight is in the opposite direction, so that's why the reflection is not clearly as compared to the other phases of the moon. So due to that reflection of the sunlight directly on towards the earth, the new phase of the moon is not visible very clearly, right? That's why we use telescope and other sources to observe the new phase of the moon, right?
Yes.
And if we consider the full phase of the moon, so when we consider the full phase, so in full phase now Earth is in between the full moon and the sun, right? That is 180-degree. If we consider the 180-degree concept, so at this phase or at the full phase moon, Earth is in between the sun and the full moon. So now only half side of the moon is facing the earth always. If you consider the any example, so only half phase of the moon is facing over the earth, but the only half surface is going to be light up by the sun, because the half part is not facing the sun. So that's why we observe the half phase of the moon very bright and half phase of the moon very dark, because of the reflection of the sunlight, right?
Yes.
So this is the concept of the phases of the moon. Any confusion?
No, sir.
Because most of related to the theoretical part, and this is the new topic, so that's why it may be something different or difficult as compared to the other topic, but mostly it is related to theory, and mostly concept we already know about, that 365 days 24 hours phases of the moon. We just need to know about their names, that is something different. Otherwise most of the concept is the basic concept which we already discussed in our sciences subject in lower secondary classes, right?
Right.
Okay, so one more topic for this class, that is the calculation part. Now we are having a topic which includes calculation in it, that is the orbital speed. Okay, by name it is clear that we are going to discuss about the speed from which planet or any uh, object is going to move in a orbit, right? So if we are talking about the earth, if we are talking about the sun, if we're talking about the moon, so all moves in an orbit with some speed. So if we want to calculate that speed, that is the circular motion around any other planet, let's suppose if we consider a sun and we also consider an orbit around it like this, and we are having a satellite or any other object which is moving in a circular path around the sun. So it means it has some speed with which it is moving around the sun or in a circular path, right?
Yes.
So if we consider any planet which is moving around the sun in a circular path or in an orbit, so let's suppose it is moving with some speed which is known as the orbital speed, because that speed is used to move in an orbit. So that is orbital speed v. And if we talk about the distance between the sun and the earth, so the distance between the sun and the earth is represented by the r, that is the orbital radius. So when it completes one cycle or the complete rotation, so for that we have to find out the value of the orbital speed or the formula to calculate the orbital speed for the different planets. So normally if we talk about the theoretical concept, so the theoretical concept is that when planet covers distance in a circular path, or let's suppose if we are talking about the distance covered by the planet in an orbit, so the distance traveled by the planet is, it travels a distance equal to the circumference of a circle, right? If we are talking about the complete motion of a planet in an orbit, so the complete distance covered by the planet in an orbit is equal to the circumference of a circle, right? Or in simple word, we can say that the shape of the orbit, right?
Yes.
So normally we consider the shapes spherical or circular. We know that they are not completely circular or spherical, but for our simplicity, we consider the shape as circular. So we know that if we want to calculate the circumference of the circle, the circumference of the circle is equals to 2 pi r, right? So that is the distance covered by a single planet in a single rotation, that is 2 pi r. So if we want to calculate the complete orbital speed with the reference of formula, so the calculation for the orbital speed will be equal to, so the formula to calculate the orbital speed, it will be equal to v is equals to 2 pi r over t, right? So we are having quantities. V represents the orbital speed. This r represents the distance, which is equal to the circumference or the distance between the orbital radius. So this is small r or capital R, if we write, that represents the radius. This represents the orbital speed. and 2 pi is a constant value. And if we talk about the t, so t is the time taken by the planet to move around the sun, or to move or to complete the distance in an orbit, right? Normally, if we talk about the Earth surface, or if we normally talk about the Earth planet, so it will take 365 days. So let's suppose if we calculate the orbital speed of the Earth, so we take the reference time which is equals to 365 days, right? Okay.
Yes.
And let's suppose if we consider the speed, uh, or we can say that if the speed of the Earth, where that is orbiting around the sun, is given, which is equals to 30 kilometer per second. So we are having the speed of the Earth and the time that required by an Earth to complete rotation around the sun. So we can easily calculate the value of the radius or the distance between the sun and the Earth, right? So that formula will also help you to find out the distance between any two planets, right?
Okay.
Or you can also calculate the time which required by that planet to completely move around any other planet if you know the value of radius and the value of speed. So that is the formula for the orbital speed of any planet. Any confusion?